Uh-huh. Yep, you got it. So we will go ahead and get started. Let me do this. So just to summarize what you were doing here, I had asked the question, what number goes in each of these boxes? You actually went ahead and did this bottom part here. For all of these ones here, what would we have to do to find this missing number? Nice. So for example, this first one here, that missing number would be
5.
Yep. The second one here, what could you do to find all of these missing numbers?
Addition.
Nice. We could add those numbers we do see. So something like this one here, that missing number is
5.
That's also 5. This next one here, we've got all multiplication problems. What could we do with those numbers we see? Very nice. So something like this one here, 3 times equals 21. Why is that? Why is it 7? Why is the missing number here 7?
We divide 3 by 21, which is 7.
Yep, I'm going to change the way you worded that a little bit. We're not dividing 3 by 21, we're dividing 21. Yes. And then this last one, for example, this missing number here is
12.
Yep, because what are we doing for all of these?
Multiply.
Right, I'm just going to put the multiplication x there. What we're doing today is similar, and we saw this before back in developmental math last quarter. But what we're doing today is similar to what we're doing right here. The difference is instead of having a box where you're finding a missing number there, instead of it looking like this, we're going to use variables. So a variable, those letters, you use a letter when you don't know the number. So instead of me saying what number goes in this box, I could say something like n minus 1 equals 4. And instead of you telling me 5 goes in the box, you would tell me n, that missing number, equals 5. The other thing we're going to be doing today is showing our work. So we're not just going to go from the equation to the answer. You're going to show your work using what you just told me here. So you said in order to solve these equations, by solve I mean find that missing number, we always have to do the opposite. So the opposite of addition, subtraction. Opposite of subtraction is addition, and so forth. We're going to be showing our work using these things you told me to show why n equals 5. I said it last quarter. I'm going to say it again this quarter. The reason we're showing our work is because I know the direction you are headed in this class very, very shortly, because this time next week we're going to be looking at equations that are much crazier than this. But I know the direction you're going in this class, and you too at home. And this idea of showing your work, showing these steps you're using to solve, are going to be really helpful in like 2 days or tomorrow or next week. But there's going to come a point where you can't just look at the equation and know what that missing number is, which is why we're also emphasizing showing how you get your answer, because we're going to be doing that same stuff when the equations get real crazy. Okay? So with that, we can go ahead and get started. The objective for today, oops, there's a 12 there, is that we are going to solve one-step equations. They are called one-step equations because there is one thing you have to do to get to the answer. And then we are going to use those one-step equations for word problems. Now, all the equations today are going to take 1 step to solve. So that's what I was saying is some of the equations today you probably can look at and know what the correct answer is without showing me how you know. But tomorrow, instead of 1 step, it'll be 2 step. And after that, it'll be 3 step. And there's going to come a point where you can't just look at the equation and know the answer. The other thing with word problems is lots of times in math, on math tests, in college, whatever it may be, they'll give you a word problem and ask you represent it with algebra. And what they mean by that is if you can write an equation, use that equation to represent it. So that'll be the other thing we're looking at today. So with that, I've said this word equation a lot. When you think of equations in math, they can have variables, they might not have variables. An equation could be something like 2 plus 2 equals 4. When you have an equation, it is just a statement, like a math sentence, that indicates the two values. So the value 2 plus 2 and the value 4 are equal. That is the fancy math definition, is an equation says the two sides are equal. And because of that, all equations have to have something in them. What does this equation have that makes it an equation? That right there, an equation has to have an equal sign in it. If it's not, if it doesn't have an equal sign, so you originally said 2 plus 3, that isn't an equation, that is an expression. We also learned that word too. Expressions are kind of just like math problems. They don't say what they equal. Equations are going to say what they equal. So we had already said what we were doing for this first part. We said we're going to have an equation, something that might look like this, and our goal is to solve it. And when I say solve it, I mean that variable right there, you want to tell me what that variable equals, what number. Now there are going to be equations, possibly this one, where you can look at it and you just know what that variable equals. For this one, by chance, do you know what that variable is?
6.
Perfect. I don't want to take that away from you. That is awesome that you can look at it and know what that answer is. Remember, the other thing we said we were going to practice today is showing why it's 6. So if you two at home are like, this is easy, I know the answer is 6, that is great, but I want to make sure you know the steps, because that's going to be what we're using this entire unit, like the rest of this month. So the steps that go with it, do you remember?
The steps.
Do you remember how to show that the answer is 6?
Subtract.
Nice. Why am I subtracting? Why subtracting and not like adding or multiplying or dividing?
Because you are getting what makes it 10.
The opposite of addition?
Subtraction.
There we go. We are always doing the opposite of what we see. So you see right now there's an adding 4. We have to do the opposite to solve. So the opposite of adding 4 is,
Subtraction.
there you go. So I'm going to write minus 4 there. Now because it's an equation, we want to keep those sides equal. So whatever you do on one side, you've got to do on the other side. So if I've got minus 4 right here, we're going to come over here and write the exact same thing. If I wrote minus 100 here, I would write minus 100 here. I write plus 50, I write plus 50. Whatever you write on one side, it's got to be the same on the other. When I do that, on this left side of my equation, and some people like to draw lines just so they can see both sides, on this left side of the equation, what happens?
That would be 4 from minus 4.
Yeah, what is 4 minus 4?
0.
0, nothing. There is a word we used for that. 4 minus 4,
Equals to 0.
it equals to 0. The word we use is it cancels out. 4 minus 4 cancels because it's 0. It's nothing, so all that leaves you on this side is the x. What about on the other side of the equation? Is there anything you can do?
10 minus 4.
Yep. 10 minus 4
6.
equals 6. So like that, we've got our answer there. If I wanted to check, do you remember how we could check these?
Yes. 6 plus 4.
So what would I write down?
6 plus 4 is
You use exactly your equation.
okay. 4 plus
X,
X.
and we know X is,
6
there you go,
equals to 10.
equals to 10. And we're going to check to see, is that true? Did you find the missing number that makes this equation true? Yeah. How many different numbers would work right there?
Different number?
So you said 6. Could I have a different number that also works there? No. So how many different numbers can we put here to make it
10.
true? Yeah. Because I could put any number I want there, but it doesn't necessarily mean
Yeah.
it's going to be true, right? So that's a good point. How many different numbers can we write there where it's what it says is true?
So
You told me 6. That's one number. Is there any other number I can put there? There is only one number that can go there, and that number is 6. So when we're solving these, you're finding that one solution, that one magical number that makes this true. What we did right here, the reason I asked you to keep that equation the same, is you are using substitution. We saw this back in our first lesson from this unit. This idea of substituting is this idea of replacing the variable with the number it equals.
So I wish the number right there is 50. You go for minus 15 then.
So if x said 15, then you would put 4 plus 15.
No, I mean the equation you did.
Okay.
Like the one you put under minus 4,
Mhm.
minus 4 there that place.
Yeah.
So I wish it says 50 plus x, so you have to do minus 52.
Yep. Bonus example. What about this one here? What are we going to need to do in order to solve that equation? What number do I need to get rid of?
Minus 3.
Good. You can always draw that line right there. We need to get rid of the number with the variable. If I want to get rid of minus 3, what do I need to do?
Minus 3 right here. Minus 3, 0, 3.
Okay. If I do that, what does this equal?
Minus 5.
I'm sorry. Did you see? I pointed on this side. What's this equal here?
0 that is cancelled.
What's the math you're doing to get 0?
Plus.
You just did this, and so tell me what you realized.
The minus sign plus the other minus sign becomes addition.
Okay.
So it's going to be 6.
Negative 6.
Negative 6.
Do I want negative 6 here?
No.
No. So what should I change? Because you said you want 0, but this isn't going to give us 0. What do I need to do to get 0 on that side?
We add.
Why am I going to add?
Opposite to solve.
That's not right. We're always doing the opposite operation. So when you told me minus 3, that wasn't the opposite. The opposite of subtraction.
Addition.
Okay. So when we add 3 on both sides, what does this give me here? So same thing.
Yeah.
So you equals 0, but because it equals 0, it's going to cancel. What's left on this side of our equation?
So 1.
What?
0.
0.
Y.
Y. And then on our other side of the equation, what are we left with?
Five.
2 plus 3 is 5. This is negative 2 plus 3.
Well, you said we keep it the larger numbers, the sign of the larger number.
Okay. So that's telling you about the sign. That's not telling you about the number. If we keep the sign of the larger number, that means our answer is what sign?
Positive.
Okay. That doesn't tell me anything about the number. I agree with positive. Negative 2 plus 3. What number does that give you?
1.
Yeah, you're just telling me it's positive. It's 1. Negative 2 plus 3 is the same thing as 3 minus 2. 3 minus 2 is 1. So we get 1 equals y as our answer. Again, if we wanted to check this, what would that look like?
That is minus 2
Mm-hmm.
is equals to 1 minus 3.
Nice. I like how you're using that equation. So we substituted 1 for y. And then what do we think? If we had substituted and it looked like this, what does this tell me?
It's wrong.
Why is it wrong?
It should be positive.
Yeah. So it being wrong would tell us if we went to check and we got something like this where it's wrong, that would tell us we need to come back up here and see what we did to get the wrong answer. It could have been the wrong steps, could have just been the wrong math and we got the wrong number, but that check can help you know if your answer is correct or not. I'm going to change up what we're doing a little bit. This was all review from the last class, from last quarter. Instead of going on to this last example, I'm going to have you do that first practice problem, the one that says solve for b. Do you see where it is? Yep, nice. All right, so I'm going to jump us back then. The real new part today is using what we know about equations to look at some word problems. So the last example I've got says, last Friday, Hillman had $59.70. Over the weekend, he received some money for mowing a neighbor's yard. He now has $91. How much money did he receive? And our first step here is what we were talking about at the beginning of this lesson. We're going to read this story problem and represent it with an equation. Now, when we're writing our equation, I've given you a clue here. I asked what your variable represents. So we know somewhere in our equation there's going to be a variable, a letter. That's one thing we're looking for. The other thing we want to look for is what type of math they're describing, what operation. So in this problem, are they describing addition, subtraction, multiplication, or division?
Subtraction.
Tell me why.
Because he had $59.70.
So that's the money he had.
So he received some money. The money is unknown.
Oh, so you've already figured out. I heard you say the unknown. So that money he received, you said is unknown.
Yeah.
What does that mean for our equation?
The variable.
Yeah, you figured out that variable. What letter do you want to use for it?
X.
Sure. So we can say X.
Because no money.
Yep, the money he received. Okay. So you already figured out our variable. That's awesome. What are we doing with that money he received? Is it being added, subtracted, multiplied, or divided in this problem?
To get it,
Exactly what it's saying here. So if he's receiving that money, what type of math does that describe?
addition.
There you go. If you're saying subtraction, your brain is a step ahead. You're thinking about the solving part. But this story here is describing addition. He's got this money. He's adding in that money he got. And then at the end, he has a total of $91. So the math it's describing as addition. It can be hard sometimes because your brain already knows what math it wants to do to get the answer. But you got it. That word receive is telling us addition. So when we go to write our equation, we're going to go through that story one more time. What's the first thing he's starting off with?
59.
Perfect. $59.70. We saw this back in our intro to variable lesson. When you're writing your equation, we're going to leave off dollar signs or words in it. We're just going to put the number. So we're starting with that. You already told me we're going to add the money he received.
Because 91.
There you go. And then we've got an equation now because I'm telling you after he does that, it equals a total of $91. Ta-da! That is our equation. So now to answer the question, how much money did he receive? That question is asking, what is X? So to find that, you can just use, if you already know what to do, you can use that. We also have this equation here we could solve. You already told me a moment ago what we need to do. What do we need to do? Yep, subtract what?
Subtract 59.
$59.70 on both sides. When I do that, what does that leave me with?
Cancel.
So we get our X equals. So if some people like that, I'll put that there. So we get X equals talk it through with me so we can do it together. What are you doing?
You add 0.
Nice. Then what?
0.
Uh-huh.
So you take 1 from the
So that leaves us with
9.
nope. You said you were going to take 1 from this. So if you take 1 away from 1,
You add it to the 0.
okay, change this one first. What number goes here?
0.
Uh-huh. And then this one?
9. 10.
10. Anytime you're borrowing, it's just like putting a 1 in front. So we get 10 minus 7 is?
3.
Yep. And then
We take away 1 from 9.
uh-huh.
To the remaining 8. 1.
Uh-huh.
1.
Yep.
And 3.
Yep. So we get, how much money did he receive?
31.
$31.30. Nice. This is really building on what we did in our first lesson, the Intro to Variables lesson. With Intro to Variables, you were kind of already doing this part. Now we're just saying what it equals to help us solve. So now that we've done that example, I'm going to have you try this one about beam pay. Did you finish writing this down? Can I erase it? No?
There's this part.
Just that part, okay. Yep. So this one here is for you.
Number 5.
Yep. Nice. Yep. Perfect. You're really great at finding that variable. And so now you just have the second part. Remember what you're solving for. What did x represent? You got it written down. X is
Money she saved.
So you've got she saved 471. She saved 471. Keep going through the word problem. Could she spend $40 on something? Tell me what you're doing to solve. Mm-hmm. Yep, you got it. Okay. We're gonna jump down, yes, to the second part. Notice all the equations we were just looking at had addition and a subtraction. There are two other operations. So this last part is focusing on how you solve equations with multiplication and division. Everything we said before is still true. In order to solve an equation, you already told me we need to get the variable by itself. And in order to solve, in order to know what steps we have to do you remember what you told me before?
Find the variable.
Find the variable. What else?
Find the opposite.
Good.
So,
All of that same stuff is still true. So we're going to find our variable, and then we want to do the opposite operation. Right here it says negative 4x. We talked about what operation that is. What type of math is happening right there? When you write something this way, does that mean addition, subtraction, multiplication, division?
multiplication.
Good. So I'll put a little note here that that means multiplication. So what this really says is negative 4 times that missing number times x equals 12. You said a moment ago, if I want to solve, I've got to do the opposite. So the opposite of multiplying by -4
Division.
is dividing. When you are showing your work for solving equations, the most common way to write that division is to use that fraction line. So instead of multiplying by -4, we want to divide by -4. I love that you said -4 and not 4. One of the biggest mistakes students make with these is they're thinking about like addition and subtraction, so they want to change the sign. But we need this number to be negative. Do you know why?
To cancel.
Yeah.
cancel the four.
Yeah. It'll become more obvious when we keep going. What is -4 divided by -4?
Cancel 0.
Nope.
1.
1. Positive 1. When these cancel and give you positive 1, we can say positive 1x. Or, we've already seen, this is just the same thing as x. If we didn't have them both be negative, you had -4 and a positive 4, that would divide and give you -1. We don't want -1x though, we just want x. So we get x all by itself, like we wanted. On the other side, 12 divided by -4. Yep, you got it. So we get x equals -3. Also, just like those other problems, you can check any equation. How could we check our equation here?
4 minus 4 times -3
Nice.
because 12.
What do you think? True? I agree. So that helps you know your answer is correct, which is great for when you're doing your homework later by yourself, or if you're at home. You can use that check to help you know your answer is correct. One last one. This one here looks a little weird. It says 2 equals y divided by 4. Looking at that one there, do you have an idea of what we want to do?
Multiply the denominator.
Ooh, math vocab. I heard multiply. Tell me first why we're multiplying.
The denominator and the other number.
We've got division, so we want to multiply, and then you're telling me multiply by the denominator, which I love. The opposite of dividing by 4 would be multiplying by 4. So I'm going to come in and say we want to multiply both, not with this marker. Maybe this one? There we go. I want to multiply both sides by 4. When I do that, what do I get on this left side here?
That's 2.
Mm-hmm. Yep. What about this right side here?
16.
Tell me how you're getting 16.
4 times 4.
4 times 4. When we learned about multiplying fractions, so for example, if we had, let's say 3/4 times 4, do you remember what we would do?
Put the other 1.
Uh-huh. So, whoop, that's not a 1. We would put it over 1. This idea is the same. Then when we're multiplying y over 4, I'll just change this to a y. We're multiplying the top, the numerator, by 4, not the denominator. If I kept going with this, y times 4 is 4y. And 4 times 1 is 4. And if I write it like that, then it looks just like this one over here, where those 4s would cancel. The same idea has been true this whole time. We're always doing the opposite so that it cancels and leaves your variable by itself. This one always gets people confused. Everyone always wants to do exactly what you said, the 4 times 4. But that 4 we're multiplying on the top,
So I'm multiplying 2.
which would mean these cancel. You don't have to go through this every single time. Just remember, you're doing the opposite to get y by itself. So we're left with 8 equals y. I think the division ones are most challenging, so we could always check. We could check by doing what?
2 is equals to 8
Yep. What do you think? True? Not true? Yeah. So that kind of helps you see why. One last example. Our last example is looking at one of our favorites. I think this is really your strength, is these word problems here. And tell me when I can erase that. Good? Okay. For this last one, same idea as the one we did before. We've got, at a restaurant, Comfort and her 3 friends decided to divide the bill evenly. If each person paid $13, then what was the total bill? And again, we're going to write an equation to represent this, and then you're going to make sure you tell me what that variable represents. Earlier, we said when you're writing these equations, there's 2 things you're looking for. You're looking for the variable. Oh, and you already told me what it is. You said the total bill. Love it. It's sometimes in the question, like if I'm asking what is the total bill, that must be the unknown. We can also see we don't know how much the bill is in the story though. So you said that's going to be our variable. What letter do you want to use? You like using X for everything. So we'll say X equals the total bill. So that was one of the things we were looking for. Do you remember the other thing we need to find? So you told me the variable. We said one thing when you're writing these equations, one thing you want to find is the variable. The other thing is the operation. What type of math is this problem describing?
Division.
How do you know?
No. Multiply 13 times 3.
Tell me why you originally said division.
I did it again.
The other one we looked at was that one about Hillman mowed a lawn, received some money. I was able to circle receive as the reason why I was saying addition. That word right there is describing addition. Yeah. Is there a word in here that's telling us what operation?
Divide.
Yep, right here. It's telling you our equation should show division. You had it and then you switched it. You're switching it to what we would need to do to solve. What we need to do to solve is always different. I shouldn't say always different. Many times is different than what it's describing. We want to write an equation showing division, showing exactly what the story says. We want to write an equation showing we're going to divide the bill at this restaurant. So going into our equation now, you told me division. What is being divided?
So X divided by 13.
X divided by 13. So that right now says the total bill divided by $13. What are you dividing the bill by? No.
Divided by 3.
X divided by 3. Where's that 3 coming from?
3 people.
The 3 people. So we're saying we're dividing the bill by how many people are eating?
Are we give the people variables too?
You only would use a variable if you don't know what the number is. So you said we're going to divide the bill by how many people?
3 people.
How many people?
4.
Where's 4 coming from? I only see the number 3.
So, 4.
Yeah. This right here is telling me there are 4 people. So we want to divide that bill by 4 people. And when you divide that total bill by 4 people, What's the rest of my equation?
Oh,
This isn't an equation yet. We need more. When you divide that bill by 4 people,
plus 13.
we know each of them pays $13. It equals $13 each. That right there is our equation. Now the second part, what's the total bill? This is the part you've been wanting to do. What do we need to do to find that total bill?
Multiply.
What you want to multiply by?
Four times 13.
Nice. Why are we multiplying by 4 and not 13?
Because the number of people.
Yep. Our variable's by itself when we get rid of that 4. So you said we want to multiply 13 by 4. That equals... I'm not going to tell you. What's it equal?
You want me to multiply?
Yeah. Nice. So what did we just find? 52 people, 52 restaurants.
Total bill?
Yeah. So we could say the total bill is
52.
$52. Ta-da! I think the trickiest thing with these is when you're writing your equation, getting that operation correct, knowing if it's addition, subtraction, multiplication, or division. My advice is doing what we did here, finding the word that's describing either addition, subtraction, multiplication, or division. You can also use your equation to go back through the story. So we can see this story is talking about 4 friends dividing up their bill at a restaurant. My equation says that bill divided by the 4 friends means each person's paying $13. This is the last one I had for you. You've got these 2 equations to try, and then that last word problem. So if you are at home, you have these 2 equations. And then this word problem. All right, goodbye.